Okay, so everything we learned yesterday in 1.6 is going to help us with everything we're doing today. So we're still going to see graphs, we're still going to see maps, we're still going to see tables, we're still going to see order pairs, which is why we learned it first, okay? So again, if you have any questions, or again, if you're lost at any point, you forget something or you're confused, please just tell me so I don't move on without you, especially since there's only a few of you in this class. It's a good time that you don't feel weird or odd to ask a question, okay? So first we're going to talk about what a function is. So a function is a relationship between the input and output that is given. Period. Right? We talked about input and output yesterday, and they use those words in independent, dependent variables. It really just means between the x and the y, or the domain and the range. We use all those words as each other. Okay? So, more information. It says that a function, also, you can stay at the end of that sentence, is a type of relation in which each element of the domain right, and in parentheses after domain put x, just to remind you what the domain is paired with exactly one, underline exactly one, that's important, element of the range. And after range in parentheses put y, and then that's the end of that sentence. Okay, what that really means, that last sentence, little star for information. When I give you stars, it's usually really important information, stuff to know. Okay, what that means is the statement which each element in the domain is paired with exactly one element of the range. What do you think that means? That means somebody can never happen more than once. Who do you think we're saying can only happen once? The x's or the y's? Read the sentence. The domain is paired with exactly one element in the range. Who can't repeat, x's or y's? Jacoby? Actually, it's backwards. It is the x's. X's pair with one answer for the y, which means x's, which is really right, the domain, cannot repeat. That's what that really means. Okay, so now what we're going to do is we're going to look at examples, whether they're as a map, as a table, as a bunch of order pairs, and we're going to say, is it a function? So that means we really only care about this starred information. As long as it doesn't do this, as long as this is okay, it is a function. If x repeats, it's not a function. Okay, so example one, it's going to be, let's start with a table, okay? Now your table is going to be left to right though. X on top, Y on the bottom. Okay, first point is going to be 1, then 4. Next one, 3 and 2. 5, then 4. Then 1 and -4. Wrote my line too long. So this is your example. It just says determine which relation, this is a relation, right? It's a table, is a function. Then it says explains. You have to explain why it is or isn't a function. This starred sentence tells us if it is or isn't a function. So look at the x's. Look at the numbers. Does it follow this rule? If it is, you write yes and say why it's yes. If it doesn't do this, say no and why no. So Jacoby, what are you going to say? No, not a function. And it says explain. So what are you going to say for your explanation, Emily? But that's in the y's. We only care about the x's. Yep, not a function. The number, you be specific, the number 1 is repeated. So remember, we only look at the x's, go, my x's can't repeat. We do not care if the y's repeat. The y's can do whatever they want, okay? The x's are not allowed to repeat. Does that make sense? Okay, that's one way to see it. Okay, example 2. Let's try a map. Okay, they label it domain and range, so let's do that. Domain here, range over here. Let's do boxes this time because they're usually, depending on my handwriting, a little neater instead of making them ovals. Okay, the numbers in my domain are -2, 0. CJ, don't look like you're taking notes. 3 and 4. My range numbers are -3, 6, and 9. So right now you don't know, right? Because a map, it's all about the lines, isn't it? Okay, let's draw some lines. Your line, first one is going to be -2 to -3, 0 to 6, 3 to 6, and 4 to 9. So now you have to remember which one represents the x's, which one represents the y's. Try this on your own. Say whether or not it's a function, and then explain your reasoning, whether it is or isn't. Hey, CJ, you put your stuff on the floor that you're not using, because you don't need your Chromebook or any of that. Thank you. So write it down. Is it or isn't a function? This is or this isn't a function. Write that first. Then explain why. Even if it is a function, you say it is a function because this is not happening. That's how you explain it. Or this isn't a function because this is what's happening that we don't like. That's how you explain that answer. I'm just checking your homework. Okay, does somebody who hasn't talked to me yet want to give me an answer? Jesse, you feel like throwing at me? Okay. Yep. And how do you tell on a map whether that something's repeating over here, Jesse? Well, yeah, but the numbers aren't repeating, but on a map, we're not allowed to repeat numbers anyway. So how do you tell on a map if something's repeat? Like, look over here. How do you tell if something's repeating? Like, you see how there's two lines going to 6 to do two different numbers right here? So that 6 is repeating over here, but over here, are there two lines going to one number? That's how we know on a map. Okay, so you are correct. This is a function because none of my x's or none of my domain was used more than once. You are correct, but make sure we see how because we don't see two lines at the same number. Okay? Do we all get that answer correct? Nod for yes. Okay, good. Maybe this time we'll do our homework there, Jacob. Okay, now let's talk about graphs. If you have a graph, there's a bunch of ways. Let's look at this one. If I just give you a picture, this one I wouldn't try to draw because I'm just going to be a little crazy. Okay? So if I just try to put points, it's really hard to just tell. Oh, man. Wake them up. Hold on. Okay. I'll make them a little bigger so all of you who are visually challenged can see. Can we see those dots now? Okay. Is it hard right away to see or know on a graph if something works or not? You can't just look at the numbers, can you? Because sometimes they don't give us numbers on graphs, do they? So there is a test. You learned this in middle school. We call it also the pencil test. That's how it used to be called, to see if something works on a graph so that no x's repeat. Do you remember what it's called? The other name for it is the pencil test, which means you use your pencil and put her down and see if any other points cross that point. Do you remember that at all? Another name is called the pencil test. What are these called? Straight up and down lines. What's a mathematical term for that? Well, that's because there's a bunch of them. What's one line called that's straight up and down? Technically, yes, but no. Starts with the letter V. Vertical. So another important thing with graphs, we have the vertical line test. Or you can use your pencil, right? You can either put pencil test. Which means if you have a picture already written for you, right? You put your pencil down or straight line or use a piece of paper, right? This is clear. You can put a piece of paper down and you put a line right there and go, do any other points go through that line, that one point goes through? If any other point does, that means this X repeats. So are there any other points on top of each other in the X's? If the answer is no for all the points, yes, it is a function. But if I had 2 points here on that same line, you see how I have 2 points on that same line together? This would be not a function because there's 2 points on the same pencil line or vertical line. Does that make sense? Let's try one I didn't draw a bunch of lines on, right? And see it. I'll flip this guy over. Okay. I'll give you a actually pretty graph. How about this guy? I think we're on example 4. It's going to look like a big, intense smiley face. You see how he's wide. He's not straight up and down on the sides. Is he going to pass the vertical line test or the pencil test? People always get this one wrong. Somebody always does. Look see how this is going out. It is not straight up and down. He's going like this. He's smiling. He's not smiling straight up. He's smiling wide. So is this a function is still the question. The answer is yes. This is a function. Because if you look at it, it's curved slowly out. So if you were to draw lines, it does not go on top of each other anywhere. Your reasoning for this, you could literally say it passes the vertical line test. That one's always tricky. So yes, this one actually is a function. What about this guy? I drew a straight up and down line. No, why not? Yep, that line I drew hits that graph twice, doesn't it? Hits that line twice, doesn't it? Yep, so this one is no, and you would say it does not pass the vertical line test. You would have to say that. Okay, now the last one, this is a confusing one just because of the way it's written. Okay, this is our normal graph. Now, we're going to have two lines on this. We're going to have an open circle up here. I'm making it extra big so you can see. I'm going to have a straight line going this way. Then I'm going to have a closed circle down here and a line going this way. Now this one, does it pass the vertical line test? All through here it does, right? Straight up and down. All through here it does. The only thing you're confused about is these points, isn't it? Now, this point is open, isn't it? This point is closed. Think about it. I'm going to close my marker so I don't mark all over my hand. Think about like spot. If one point's open and one point's closed, that means I could fill in this spot with that point. So that does not include that point, and this does. So because one is open and one is closed, that is actually a function. If they were both closed, the answer would be no. If they're both open, the answer would still be yes. But since you have one of each, you're okay. So this one is actually still yes. Okay. Now let's look at equations. Because I think there are some. Okay, we're doing good. Okay. Now these, let's talk about them if they were in equation form. If you have an equation that has x and y, so y equals 4x plus 5, I just made that up. Doesn't matter what it is. Okay, these ones are hard. When you have anything with only x and y, one of each variable, this still makes a line. Because these kind of equations, which is what the next chapter all is, which is silly that they make you do this early. But this guy makes a nice pretty diagonal line. So if you see just a y and just an x, no powers on them or nothing, this is yes, it is a function. Because they're both together. Y and x are meant to be together. They're like a pair. They're a perfect function. Okay. If you have powers on them, if it's anything, it should be still fine. I don't think I see any. Yeah, we're good. Not going to challenge you on that. Now, the hard ones are these guys. And I'll show you the picture so you can see them. We have y equals any number we want. I'll pick a number 5. And then we're going to do the same thing with x equals a number. We'll pick 3. Now these guys, when y and x are alone, sometimes they work and sometimes they don't. I'm going to show you that. So it helps to think about a graph. Which one is my y-axis and which one is my x-axis? Again, I should probably draw that. Huh? I'm sorry, I'm just making these bigger. Which one? Up and down is y or left and right is y? Up and down. Yep, this is our y-axis. This is our x-axis. I'll label both of them. Okay, so on here, where would y equal 5? My picture too small. Where would it be? It's on the up and down line. We always start at the intersection. Where would positive 5 be? It would be up 5 because it says y equals 5. So it'd be up here somewhere 5. I just can't see it because I didn't draw my picture properly. Now this is the hard part about these equations, and we will talk about this so much more later. Y's equation, the picture, you know how the axis is up and down? Its graph is opposite. It's left and right. So its picture, its line goes left and right. I'm just dotting it so you can tell the difference. So that guy, a left and right line, does he pass the vertical line test? Does this guy pass the vertical line test? Yes, he does. Because your graph is opposite of your line. But the x's, x equals 3. If we start here, our x-axis is here. Where is positive 3? To the right or to the left? To the right. Okay, just guess 3. Again, our picture is opposite of our axis, so our axis goes left or right. So what's our line do? Up and down. Can a vertical line pass the vertical line test? Think about it. There's a bunch of points on this line, like thousands of points on this line. So can a line pass a lines test? No. This is the trickiest part. And the biggest positive, I guess we would say, is that we will really get into this when we learn how to graph them. Yes, sir. I was about to tell Katie that she's getting real close. We got like 5 minutes. We're getting real close. Okay? Okay. Now, it's good because we have one topic to talk about. We'll do a practice problem, and then we'll go to the restroom, and then we'll work a little bit more, okay? Now, last thing we have to talk about, it is called function notation. Okay, which is really just saying a way we can write functions. So an equation uses this. Y equals, I'll just use the same example, 4x plus 5. That's an equation. Y equals 4x plus 5. A function, this is also a function because we just talked about it. The only difference is it's going to say f parentheses x, close your parentheses, equals 4x plus 5. Look at those two things. What is the only difference between this guy and this guy? Jacoby. Huh? This and this is the only difference, right? I'll give you a little hint. Y is the same thing as this guy. They're the same thing. The only difference is They use y when we're talking about equations. But if we say, hey, we're talking about functions because we're being fancy, they're going to use this. I'm going to write how you say it. You say it f of x. That's how you say that statement, f parentheses x parentheses. That's how you say that, f of x, which means the function of x. Okay? We use this so we can solve stuff. So if you have an equation, well, now we have a function. So f of x equals negative 4x plus 7. Okay? And we want to find, it says find each value. So we want to find whatever it tells us to, okay? First one we're start with, part A. We're going to find f of, you're not going to put an x there. Now I'm going to write the number 2 there in the parentheses. That's what it says. What's the difference between this guy and that guy? The number 2 replaced what? X. What math word do we use instead of saying replaced or plug in? What's that math word? Substitute. So we're going to take 2 and we're going to plug it in for x into that equation. Every time you plug in something to equation, what should you put around that number? Parentheses. So I'm going to write negative 4 parentheses 2 plus 7. Then I'm either going to use my brain or I'm going to use my calculator. Remember, if you use your calculator, please use the parentheses. A lot of you miss these kinds of questions at the end or during your quiz, because especially with negative signs, because you did not use your parentheses correctly. And you're going to write your final answer, f of 2 equals, because you have to tell me what that answer is, and then type this in or do the math and tell me the single digit number answer it is, which you plug it in and you get what, Risa? Negative 1 is the correct answer. Did we all get negative 1? Yes? Okay. Part B. We're getting closer. Now let's try f of negative 3. So what are we going to plug in? What are we going to do? What are we going to do? We still have this equation, the original example. You're going to plug it in for x. You're still using the same equation that's up here. You're going to want to pay attention to the right thing. Also, then look, it's going to write this. It wrote plus 1 at the end. Scary. Does this have anything to do with this parentheses? No. Do this first. Plug in negative 3 into that equation. So negative 4, plug in negative 3 in parentheses, plug it in your calculator, that, plus 7. Find that answer. What is negative 4 times negative 3 plus 7? Emily? 19. But the end of our part B said what? Plus 1. What do you think we're going to do? Plus 1. So you do that at the end after you plug stuff in. So then what's my final answer going to be? 20. Does that make sense? Yeah? That's not so bad? Let me see. Can you move your head for just a second? Actually, no, you're good. Oh, that was farther than it was. If I pause this, does it actually pause it? No, it doesn't. Just pauses the video. Okay. I'm going to write down the problems that we're going to do for the people that are watching at home. And we're going to go take a bathroom break. Okay? So I'll write these down for us. The only thing that's sometimes scary is you want to pay attention. So if I write f of x equals, I'm going to make this up, 2x minus 3, but then I write g of x equals x squared plus 3x. See how there's two different equations? So if I say find g of 3, you want to look at the g equation when you plug it in, right? So you know how these all said f of something because we only had one equation? So the only scary part about this is you want to pay attention to where you're plugging it into, okay? So I'm just going to write these down, and then we are going to use our bathroom break, and then we'll come back and do this. Okay. You sound like your homework, so okay. Okay, so I'm going to stop this. I lost my cursor. There it is.